Right, I think that when I go to present mode, I'm gonna lose you on my webcam. I'm sorry, but I can't figure out how to fix that on my Chromebook here. All right, so let's set up our timer so that I can talk really fast over the things I gotta say. All right, so today we're going to be talking about solving word problems, why it's important, and how we can teach our students to do it better. My name is Anthony Zortea. I'm a 5th grade math teacher, and solving word problems is what we do all day, every day. So when I talk about word problems, we're thinking about this kind of, if a train leaves Georgia at 5 o'clock and goes 42 miles an hour, when will it catch up with the yada, 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 yada? So this is a very typical word problem. And it includes solving a real life problem, but using the operations that we've learned in class. Now, one of the biggest obstacles I found here is that parents don't understand this system because they say this is not how we did math. When we did math, it wasn't, oh, there's multiple possible answers. Oh, make a model, try to figure this out. What they're used to and what they want to see is multiplication charts. Drill it, drill it, drill it. Long division, drill it, drill it, drill it. Multiply, pull down, bring the zero. So they're used to these procedural systems, and that's just not how math is done in our age. Also not how math was done 4,000 years ago. This is a Babylonian tablet found 4,000 years ago. The second most common type of Babylonian tablet found included word problems for students in architecture school. The word problems had to do with how to build irrigation systems, how to build silos. So they would learn about circumference, they would learn about multiplication, but then importantly, their teachers knew that they had to say, okay, but what about these real life problems? And they realized that math is a tool to solve a problem. How can we use circumference? How can we use area? How can we use volume to solve real life problems? And when math becomes a tool, it's a lot more interesting and our students become more motivated to use it. The state agrees on this. This is another reason our students are going to see 92% of their PSSA is going to be word problems, while only 3 of the, I believe, 52 questions are no calculator operation problems. So the vast majority of what they're going to see. So what are we going to do about it? Well, we can teach our students metacognitive skills. We can use the schematic approach to help them better understand word problems, and we can use the interest-based approach. So as we go, I'm going to talk about each one of these skills. The first being metacognitive. This is thinking about the process. This has our students be more flexible problem solvers because they're not tied down to one single system, but rather they're able to think about the problem and think about what they know. Couple questions to ask themselves. First, do I understand the problem? Can I retell it in my own words? If they cannot retell it in their own words, that says, okay, I got to go back. They're thinking about their thinking. I don't get it. I have to go back. A second question they can ask themselves is how does this relate to other problems? Does this sound like an addition problem that I did before? Does it sound like a division problem I did before? If they're just guessing, if they're just throwing operations up in the air and seeing what happens, that tells their brain, whoop, I don't understand this. Let me go back and check. Are there similar problems? Last, does my answer make sense? Could Sally really fit 60,000 apples in her basket? Maybe if the basket was that big. So again, these questions ask us to reflect on what we know. They're not specific skills, they're meta skills that helps process. The second type of specific skill we can teach is the schematic approach. The schematic approach says, hey, we're going to take our word problems and we're going to put them into 3 to 4 categories. This is a takeaway type. This is a compare type. This is an added up type. And when we have those 3 to 4 types of problems, we can say, oh, okay, I know what type this is, and I know what model to use. For example, the top left might be an add-on type of problem. So if I know it's an added up, oh, that's the model I'm going to use. The model on the bottom right is maybe something more calculated or more complicated. The third skill is an interest-based approach. And this is where we add the students' names and activities into a word problem so that they can connect with the word problem and give themselves a better opportunity to solve it. So the teacher can be responsible here to set the problems up, but it more relies on the student. If a student takes a test, they have to know how to rewrite that problem with their own name and their own activity. So instead of saying Sally bought 5 apples, you could say I bought 5 video games. That actually increases their ability to answer the problem. So now we're going to take those 3 things and we're going to put it into a rubric, because the rubric gives us clear goals for the student to say, oh, this is what I need to do to solve a word problem, instead of making it this kind of wild, there's so many going on. So for metacognitive skills, on our rubric, we have how many of those questions did you ask yourself? Oh, I only asked myself one of those questions. I need to improve that. The schematic approach, oh, I didn't think about how past problems connected to this. I need to make sure I do that. The interest-based approach, did I include myself in that problem? And by the end of this, they're going to know exactly when that train is going to reach Georgia, or when the train from Georgia is going to meet up with the trains that left Philadelphia. Well, hopefully at least. So thank you for listening, and have a fantastic evening as I figure out how to end the video. On your marks, get set, go. Got it. Got it.